In this video, you're going to learn how to use a library that has promises built in. We're going to explore the Axios library, which is really similar to request, although instead of using callbacks like request does, it uses promises, so we don't have to wrap our calls in promises to get that promise functionality. We're actually going to be recreating the entire weather app in this video. We're only going to have to write about 25 lines of code. We'll go through the entire process, taking the address, getting the coordinates, and then fetching the weather. To do this, I'm going to duplicate app.js because we do configure yargs in here and we're going to want to carry over that code to the new project. There's no need to rewrite it. Right here, I'm going to duplicate app.js, giving it a new name, app-promise.js. Inside of here, before we add anything, let's go ahead and rip some stuff out. I'm going to be ripping out the geocode and weather variable declarations. We're not going to be requiring any files. Then I'm going to remove everything after our yargs configuration, which in this case is just our call to geocode address. Excellent. Now that we have a clean slate, we can go ahead and get started by installing the new library. Before we run the npm install command, I want to show you where you can find the documentation. You can get it by Googling npm Axios, A-X-I-O-S. Right here, we have the Axios npm library page, where we can view all sorts of information about it, including the documentation, which we have down below. Here you can see some things that look familiar. We have calls to then and catch, just like we do when we use promises outside of Axios. Over on the right-hand side, you can see this is a super popular library, and the most recent version is 0.13.1. That's the exact version we're going to be using. Feel free to come back to this page when you use Axios in your projects. It has a lot of really good examples and documentation. For now, though, we can install it. Back inside of the terminal, I'm going to be running npm install. The library name is Axios, and I am going to specify the version 0.13.1 with the save flag, updating the package.json file. Now I can go ahead and run the install command, which is going to install it, and over inside of our app promise file, we can get started by loading in Axios up at the top. I'm going to make a constant called Axios, setting it equal to require Axios, just like this. Excellent. And now that we have this in place, we can actually start making the calls down below. And this is going to involve us pulling out some of the functionality from the geocode and weather file. So what I'm going to do is close all of my files except app promise. I'm going to open up geocode.js, and then I'm going to open up weather.js, because we are going to be pulling some of the code from here, things like the URL and some of the error handling techniques. Although we'll talk about the differences as they come up. The first thing we need to do is encode the address and get that geocode URL. Now this stuff happens inside of geocode.js. So what I'm going to do is actually copy this line exactly, where we create the encoded address and paste it over here, down below the argv variable. Now we do need to tweak this a little bit. The address doesn't exist. What we have is argv.address. Perfect. And now we have the encoded address. The next thing we need to get before we can start using Axios is the URL we want to make the request to. I'm going to grab that over from the geocode.js file as well. I'm going to take the URL from the opening tick to the closing tick, copy it, and paste it over in app promise.js. Here, what I'm going to do is make a new variable called geocode URL, setting it equal to what I copied over from the other file. Now we do use the encoded address variable inside of here, and that's fine because it does exist right here. So at this point, we have our geocode URL, and we can get started making our very first Axios request. In this case, we're going to be taking the address and getting the latitude and longitude. To make our request down below, we're going to call a method available on Axios, axios.get. Get is the method that lets us make our HTTP GET request, which is exactly what we want to do here. And it's really simple to set up when you're expecting JSON data. All you have to do is pass in the URL, which we have in the geocode URL variable. There's no need to provide any other options, like an option letting it know it's JSON. Axios knows how to automatically parse our JSON data. And what get returns is actually a promise, which means we can use .then in order to run some code when the promise gets fulfilled or rejected, whether things go well or things go poorly. Inside of then, I'm going to go ahead and provide one function for the moment. This is going to be the success case. The success case is going to get called with one argument, which the Axios library recommends you call response, although technically you could call it anything you like. Now in here, we're going to get access to all of the same information we got inside of the request library, things like our headers, things like response and request headers, as well as the body information, all sorts of useful info. What we really need though is the response.data property. I'm going to go ahead and print that using console.log. Console.log response.data. And now that we have this in place, we can go ahead and run our app promise file, passing in a valid address, and we can see what happens when we make that request. Over inside of the command line, I'm going to use clear to clear the terminal output. Then I'm going to run node app-promise.js, passing in an address. I'm going to use a valid address. I'll go ahead and use 1301 Lombard Street, Philadelphia. Perfect. The request goes out, and what do we get back? We get back the results object exactly as we saw it when we used the other module. The only difference in this case is that we're using promises built in instead of having to wrap it in promises or using callbacks. And this is really fantastic. Now, aside from this success handler, we can also add a call to catch, which is going to let us catch all of the errors that might occur. We're going to get the error object as the one and only argument, and then we can do something with that error object. Inside of here, I'm going to kick things off by using console.log to print the error argument. And now we can go ahead and simulate an error by removing the dot, and we can see what happens when we rerun the program. Now, I'm doing this to explore the Axios library. I know exactly what's going to happen. That's not why I'm doing it. I'm doing it to show you how you should approach new libraries. When you get a new library, you want to play around with all the different ways it works. What exactly comes back in that error argument when we have a request that fails? That's important information to know, so when you go ahead and write a real-world app, you can add the appropriate error handling code. In this case, if I rerun the exact same command, we're going to get an error. And as you can see, there really is nothing too pretty here. We have a lot of very cryptic error codes, and even the error message property, which usually contains something good, does not. Get address info, and then we have an error code followed by the URL. What we want to do instead is print a plain text English message. To do this, we're going to use an if-else statement, checking what the code property is. This is the error code, and in this case, E not found, we know it means it could not connect to the server. Down inside of the error handler, we can add this by having if and checking the condition if e.code equals E not found in uppercase. If that is the case, we're going to print some sort of custom message to the screen using console.log. Console.log, unable to connect to API servers. Excellent. Now we have an error handler that handles this specific case. So we can go ahead and remove our call to console.log. Now if we save the file and rerun things from the terminal, we should get a much nicer error message printing to the screen, and that's exactly what we get. Unable to connect to API servers. Now I'm going to add that dot back in so things start working, and we can worry about the response that comes back. Now, as you remember, inside of the geocode file, there was some things we needed to do. We've already handled this error, but there is still another error. If the body status property equals 0 results, we want to do something. We want to print an error message. To do that, what we're going to do inside of app promise is create our very own error. We're going to throw an error inside of this function. That error is going to cause all of the code after it to not run, and it is going to move right into the error handler down below. Now, we only want to throw an error if the status property is set to 0 results. We're going to add an if statement at the very top to check. If response dot data dot status equals in uppercase 0 underscore results. If that is the case, then things went bad, and we do not want to move on to make the weather request. We want to run our catch code down below. To throw a new error that our promise can catch, we're going to use a syntax called throw new error. This creates and throws an error, letting Node know that something went wrong, and we can provide our own error message, something that's readable to a user. Unable to find that address should get the job done. And this is a message that's going to let the user know exactly what went wrong. Now, when this error gets thrown, the same code is going to run down below. And currently, we only have an if condition that checks if the code property is eNotFound. What we're going to do is add an else clause. Inside of here, we can print the error message, which is the string we typed up above, using the e.message property. Console.log e.message. If the error code is not eNotFound, we'll simply print the message to the screen. This is going to happen if we get 0 results, so let's go ahead and simulate that to make sure the code works. Over in the terminal, I'm going to go ahead and rerun it, passing in a zip code. At first, I'm going to use a valid zip code 08822, and I should get my data back, and I do. Then I'm going to use an invalid one, 00000. When I run this request, I do get my error, unable to find that address. By calling throw new error, we're immediately stopping the execution of this function. So the console log down below never prints, which is exactly what we want. We move right on to the error code below. Now that we have our error handler in place, we can go ahead and start generating that weather URL. In order to generate that URL, I'm going to go ahead and copy the URL from the weather file, taking it with the ticks in place and moving it over into the app promise file. I'm going to make a new variable called weather URL, setting it equal to exactly what we copied. Now the weather URL does need a few pieces of information. We need that latitude and that longitude. We have two variables, lat and long, so let's go ahead and create them just above, getting the appropriate value from that response object. Var lat and var long. Excellent. Now in order to pull them off, we have to go through that process of digging into the object. We've done it before. We're going to be looking in the response object at the data property, which is similar to the body in the other library. Then we're going to go into results, grabbing the first item, accessing the geometry property. Then we're going to access location.lat. And now we can copy what we just typed, create an equal sign for the longitude variable and paste it here, replacing lat with lng. And now we have our lat long variables. Now, before we go ahead and make that weather request, I do want to print the formatted address because that's something the previous app did as well. I'm going to take our console.log down below, and instead of printing response.data, I'm going to dive into the data object, getting the formatted address. This is also on the results array's first item, and we're going to be accessing the property formatted _ address. Perfect. Now that we have our formatted address printing to the screen, we can go ahead and make our second call by returning a new promise. This is going to let us chain these calls together. We're going to return a call to axios.get, passing in the URL. We just defined that. It is weather URL. Now that we have this call returning, we can go ahead and attach another then call right between our previous then call and catch by calling .then, passing in one function, just like this. This function is going to get called when the weather data comes back. We're going to get that same response argument because we're using the same method, axios.get. Inside of here, we don't have to worry about throwing any errors since we never needed to access a body property in order to check if something went wrong. With the weather request, if this callback runs, then things went right, and we can go ahead and print the weather information. In order to get that done, we're going to make two variables, one called temperature. This is going to get set equal to response dot data. Then we're going to access that currently property. Then we're going to access temperature. And we're going to pull out a second variable, the actual temperature, or apparent temperature, which is the property name. Var apparent temperature. We're going to be setting this equal to response.data.currently.apparent temperature. Now that we have our two things pulled out into variables, we can go ahead and add those things inside of a call to console log. I chose to define two variables, so I didn't have to add these two really long property statements to the console log. I can simply reference the variables. Console.log. And we're going to be using template strings here so we can inject those two values inside of quotes. It's currently, followed by the temperature. I'm going to inject that right here. Then I can add a period. It feels like, followed by the apparent temperature. I'm going to inject that right here. Now that we have our string printing to the screen, we can go ahead and test that our app works as expected. I'm going to save the file, and over inside of the terminal, I'm going to go ahead and rerun the command 2 commands ago where I had a valid zip code. When I run this, we do get the weather info. For Flemington, New Jersey, it's currently 84 degrees, but it feels like 90. If I go ahead and run something that has a bad address, I do get the error message, so everything looks great. I'm going to test it out with one more zip code, my current zip code 19146. When I run it, I get the appropriate address and I get the weather info printing to the screen. And this is fantastic. By using the Axios library, we're able to chain promises like this without needing to do anything too crazy. The Axios get method returns a promise so we can access it directly using then. Here we use then once to do something with that geolocation data. We print the address to the screen, then we return another promise where we make the request for the weather. Inside of here, our second then call, we go ahead and print the weather to the screen. And we also added a catch call, which is going to handle any errors. If anything goes wrong with either of our promises, or if we throw an error like we do here, catch is going to get fired, printing the messages to the screen. This is all it takes to use Axios and set up promises for your HTTP requests. Now, one reason people love promises over traditional callbacks is that instead of nesting, you can simply chain. So your code doesn't get indented to crazy levels. As we saw in app.js, we went a few indentation levels deep just to add 2 calls together. If we needed to add a third, it would have gotten even worse. With promises, we can keep everything at the same level, keeping our code a lot easier to maintain. And now that you know a little bit about promises, we are done with the async section. Obviously, we're not done with async. Every single thing we do throughout the rest of the sections in this course is going to be async. In the next section, we're going to start creating web servers, which will be async. We'll make APIs, which will be async, and we'll create real-time Socket.io apps, which will be async. It is a critical part to Node.js. All we've done here is we've gone over the very basics of callbacks and promises. We've gone through a few examples, creating a pretty cool weather app. But now it's time to move on to creating Node apps that we deploy to servers, and those servers are accessible via anybody with a web connection. That is coming up in the next section. I am super excited to get there, so stay tuned. I will see you then.